Good morning. My name is Mohammed Abdul Hamid, and I'm a senior in the science research program. And my presentation is titled "Effectiveness of Exercise and Cognition in Neural Efficient versus Non-Neural Efficient Pathways." And I'll get into this as I go. Oh yeah. So before we begin, I'd just like to explain the shift in my focus from last year. Last year I was kind of geared towards proving that exercise can be used as a quick, effective cognitive enhancer in anyone pretty much. But many studies have already proved this, and I kind of shifted towards figuring out whether a similar stimuli can be used in brighter individuals. And brighter individuals, their brains work kind of differently because of the neural efficiency hypothesis, which has been scientifically proven, and I'll get into this as we go. So there have been many studies that prove that exercise can be used as a cognitive enhancer, and I think I'm missing, oh, never mind. Two of my slides got switched. That's fine. So for again, cognition is the process of acquiring understanding and knowledge through thought, experience, and the senses. And the optimal brainwave state for cognition is the alpha brainwave state. Basically, what brainwaves are the electrical impulses in our brain, and they're measured via electroencephalogram, which is just an EEG. And relative to my study, the neurosci, which is a simple device, one electrode attaches to your forehead and one attaches to your earlobe, and your electrical impulses are displayed as wavy lines, as you can see here. And this is the alpha brainwave state, which has a frequency of 7 to 13 hertz. And your brain just works better because you're in a peaceful, relaxed state, you're more creative, and you have better understanding of things. So cognition in relation to exercise. One study that I read had to do with recumbent cycle ergometer, which is just this bicycle-looking thing here. And during and after use of the recumbent cycle ergometer, there were increases in alpha and theta frequencies. And how this is pertinent to my study, my proposal is that alpha frequencies increase, and as I mentioned before, alpha is the optimal cognition state, and I want to implement this in my study. So the neural efficiency hypothesis states that brighter individuals will show less brain activation when completing a cognitive task with the same difficulty than less bright individuals. So there's less cortical activation, and your brain just works more efficiently. So my objective is to assess whether neural efficient pathways can be affected by exercise as effectively as they can be in non-neural efficient people. So if my brain works more efficiently than someone else's, if I exercise, will I be as effective as the other person? And if so, can it be used as a cognitive enhancer as well? So I read an article in the Harvard Men's Health Watch, and it said that moderately intense exercise is the key to better brain functioning because it increases memory, concentration, and mental sharpness. And the most optimal exercise is moderately intense exercise, which implements the core and multiple parts of your body. So my exercise task includes 20 seconds of jogging in place, get the core going, 5 to 10 squat thrusts, which is also use of the core, and 5 to 10 jumping jacks, which is pretty much everything. My cognitive task is called the Wisconsin card sorting task, and it's been used as psychological cognitive assessment. When people go through brain damage, it's kind of used as to see how much cognitive functioning has been impaired. And basically, you're presented with 4 cards, and you have to match one card with one of these. You can sort by color. So if I were to sort by color, I would have to choose the 4 yellow stars. If I were to sort by number, I would choose the 3 blue pluses. And if I were to sort by shape, I would again choose the 4 yellow stars. The way that this test works, there are 60 trials, and the only feedback that you receive is either correct or incorrect. So a lot of it has to do with cognitive reasoning, and you have to figure out through trial and error if you're matching by shape, color, or number. This is data that I received from this test, and basically the first column has to do with which card in a set of 64 cards was presented to you. This represents which card was of the 4 was the correct card to choose. So again, I presented 4 cards here, and this column just represents which one is the right answer. As for, I mentioned there are 60 trials. The third column represents one of 10 trials, and the first 10 trials all happen to be shaped. So here's the shape that I was given, how many numbers. So I was given 3 stars here. This right here is 3 stars, and they have to be yellow as well. And it's just matching with my example. Excuse me. Here's the color, 3 yellow stars. Here's the reaction time in milliseconds. And if reaction time kind of is shortened, I can look to make links with exercise because it increases mental sharpness. And here was, these are twos and ones are incorrect and incorrect respectively. So the first 2 were wrong, and then I got into the hang of it, and then I started getting right answers. And if you see here, I matched up. I had to choose a 2, I chose a 2. I chose 2, chose a 2. I was supposed to choose 1, I chose 3. I was supposed to choose 3, I chose 4. That's my first 2 trials were incorrect. So after putting participants through an exercise, I plan to increase alpha and theta frequencies, mostly in non-neural efficient pathways, and I can judge accordingly in people who are neural efficient. I plan to see enhanced cognitive performance by non-neural efficient pathways because many studies have already proven this. After you exercise, your brain just works more sharply. Something I also may potentially see, which is the focus of my study, is maybe neural efficient pathways are less affected by exercise, and therefore exercise can't be used as a cognitive enhancer there. So for further research, obviously a larger sample size would be ideal, and a different or more effective exercise task could be implemented. For my study, I used something that spanned under a minute, and I just wanted to uphold the modernly intense standard. And further research could focus more on brainwave activity after exercise and neural efficient pathways. As I mentioned, I'm looking to see whether alpha frequencies increase in neural efficient pathways, but a number of factors could be tied into how neural efficient brains are affected by exercise. And basically my overall goal is to see whether we can implement similar stimuli in regular people as we can in brighter individuals. Questions? So I came across the different components of my study throughout. I mean, mine is kind of unique to me, and that's like the purpose of doing a research study. I came across the exercise study, which gave me the link between exercise and brainwave activity, which I mentioned alpha and theta frequencies increase. I came across a number of studies that said that alpha was the optimal cognitive state, and this second study here was actually focused on using neurofeedback to increase alpha frequencies in people so that they could perform cognitive functions, cognitive tasks better. So I made the links myself, and I want to see if we can use similar stimuli in neural efficient people. Okay. The test? Yeah. Okay, yeah. Do you care about the data, or do you want to see this in the data? Okay. So I'm gonna go through the whole thing again. Basically, you're presented with 4 cards, and the whole test has to do with cognitive reasoning. So the test doesn't tell you anything about what, I mean, it gives you instructions beforehand, like you can match either color, number, or shape, and then the only feedback you'll get from then on is correct, incorrect. So your first 2 trials, you're basically, you don't know what you're matching with. So let's say I think I'm going to match by color. I'm going to go here. They tell me it's wrong. Then I switch over to number, and then they tell me it's right. And now I know I'm with number. So this column is kind of relevant. It's just, I have 64 cards that I can choose from, and this is which card you're presented with. So this second column is which card you should have chosen of the 4. So you should have chosen the first card to get a correct answer. Here I chose the third card, which gave me a 2, which means wrong. Here I should have chosen the third card, and I chose the fourth card, so I should have chosen this, but I chose this, which made me wrong. This middle set of columns is basically you're supposed to match by shape. This was the shape you're given. This was how many. So right here I have 3 yellow stars. 3 yellow stars. And this is the number of trials where you're matching the shape. So the first 10 trials will all be shaped. Oh, and this is reaction time in milliseconds. Again, maybe exercise decreases your reaction time and you work quicker.
Yeah, good. You have to figure out which of the 3 options has to be, like, is that consistent throughout the whole test? So if you have like color, shape, or number, you have to figure out which one you have to choose and it will be consistent.
You mean like is it going to be shaped for the whole test?
Yeah.
No. That's why like it's cognitive reasoning. After the first 10 trials, it's going to switch, and then you can match these according to color and number, and then it switches again for 60 trials. Can I add one thing?
Yeah, okay, because I have a bunch of questions.
Okay. The one thing that I have not yet figured out is you finding a baseline for neural efficiency. It's kind of an abstract concept that like some people's brains work more efficiently than others, and so I have to use a baseline cognitive test to separate my participants into one neural efficient group, and then these people are non-neural efficient.
That basically was my first question. How are you going to identify neural efficient people, right? You're basically saying neural efficient people are bright people. You're crossing languages. How are you going to identify it? You're going to be using NeuroSky and baseline tasks to identify your groups. All right. So your overall premise is that we know exercise is going to increase output. It's going to increase cognitive ability. Your true question is, if somebody's already neurally efficient, is it going to have the same effect?
Yeah.
That's kind of what your correlation is. So we do expect to see a percent change in cognitive ability equal with a low neural efficient, a high neural efficient.
Yeah,
that's the way to put it.
Yeah. I mean,
okay.
Yeah, that's my goal.
So just kind of go slowly back to your slides. I had your question slowly.
Oh, sorry. Just working backwards?
I'll say back. What do you mean by less cortical activation? What are you talking about? Are you talking about like cortical hormone?
No, I think it has mostly the prefrontal cortex. I think it's less used in neural efficient participants when doing cognitive tasks. I have to check up on that, but I'm pretty that's what I came across.
Is that where the alpha waves are generated? Like when you're measuring alpha, beta waves, are those waves coming from different areas of the brain? Or is it a measurement of, or the brain waves measuring if 6 of the 7 regions of the brain are activated? Does that give you a theta wavelength measurement? Or do theta wavelength measurements come from a certain particular area of the brain?
Yeah.
Question.
They're not specific to regions of the brain.
They are or they're not?
They're not.
Okay.
But in different regions, a brainwave can be more frequent than in another region. Okay. So in the hippocampus, I can probably have increased alpha wave states and my cognition can be better. Whereas in the prefrontal cortex, my theta frequencies can be higher, but lower in the hippocampus. So depending on what you're doing, brain usage kind of alters frequencies accordingly. And when you sleep, like also frequencies lower in most parts of the brain and stay active in other parts. Does that answer your question?
Yeah. What's your next step? What do you do now?
I'm programming something so I can use the NeuroSky to, I actually can't recall, but remember I downloaded the program?
Yeah.
I have to set up a program that allow me to it'll give me numerical data on alpha frequencies, and then I can implement that to start getting my baseline and seeing, okay, how can I classify people as neuroefficient and non-neuroefficient?
Any more questions? All right. Good job.
Is there a way to stop the snag it?
Yeah, stop there. Just hit stop. You're gonna pull it over. Pull your mouse from the right screen to the left screen.